Hello students, today we will start the chapter Structure of Atom. This is the first lecture. In this lecture, we will study about introduction to the atomic structure and discovery of electrons. Within discovery of electrons, we will see the cathode ray experiment, J.J. Thomson experiment and Millikan oil drop experiment. So, before starting the chapter, we need to know what is an atom. The atom is originally derived from the Greek word atomio, which means uncuttable or non-divisible. That is, atom is a particle which cannot be divided. For a long time, it was believed that if you break up a matter, any matter, the smallest particle that we get is an atom. But there was no scientific basis to it. The first scientific basis of atom was given by John Dalton in 1808. So, John Dalton proposed some postulates which we call Dalton's atomic theory. In Dalton's atomic theory, the first point was all matter is made of tiny indivisible particles. Called atom. These atoms, he said that the atoms of same elements are of same mass and size. And the atoms of different elements are of different mass and size. The third point said that atoms cannot be created, it cannot be destroyed, and it is indivisible. And he said that the atoms can combine, separate or recombine to form reactions. These were the postulates of Dalton's atomic theory. But these theory had certain limitations. For example, now in modern science we know that atoms have further smaller particles which are called subatomic particles like electrons, protons and neutrons, which Dalton's theory didn't state. Dalton's theory also didn't explain about isotopes and isobars. He said that atoms of the same elements are of same mass and size, whereas of different elements of different mass and size. But we know about isotopes. Isotopes are the same elements with different mass. Like we have hydrogen, that is 1H with mass number 1. There are two other isotopes of hydrogen. They are deuterium and tritium with mass number 2 and 3 respectively. Also, we have isobars. They are different elements with same mass. For example, argon and calcium. Both of them have atomic mass as 40. Dalton's atomic theory didn't explain these things. Also, he said that the atoms of same elements are same mass and size, so they should be identical. But we can see allotropes, like carbon has different allotropes, diamond and graphite for example. They are made up of carbon only, but they have totally different physical and chemical properties. Their appearances are also totally different. Dalton's atomic theory do not explain about the allotropes. So, Dalton's atomic theory was regarded as backdated, but the most important concept that we have from it is of the atoms. Another point was that atoms recombine, separate or combine in simple molecular ratios. They also have many exceptions, like the formula of sucrose is C12H22O11. If we take the ratio of carbon, hydrogen and oxygen here, we see 12, 22 and 11. We cannot convert it into any simple ratio. There also Dalton's atomic theory failed. So in the modern science, there are various subatomic particles, but the most important are three of them. One is electron, which we write as E0 minus 1, where 0 is the mass and minus 1 is the charge. The second one is proton, where the mass is treated as 1 and the charge is plus 1. And the third one is neutron. Mass is 1 and the charge is 0. So atoms have three different types of particles. Electrons are negatively charged, protons are positively charged and neutrons are neutral. So the atom as a whole remains neutral. There are other subatomic particles also which are discovered later, like positron, neutrino, boson, etc. But here we will study only about electrons, protons and neutrons. So we can start about discovery of electrons. Before starting discovery of electrons, we need to know about certain concepts. Michael Faraday in around 1830s discovered the concept of electrolysis. What is electrolysis? He said that there are two electrodes it can be of metal, and when these two electrodes are put in a solution containing electrolytes, electrolytes are mostly ionic compounds, and electricity is passed through it, it is observed that some reactions happen at these electrodes and some matter is deposited. It was observed that positively charged particles moved towards the negatively charged electrode, that is the cathode, and the negatively charged particles moved towards the positively charged electrode, that is the anode. If these are two electrodes, this is the cathode which is negatively charged and this is the anode which is positively charged, and suppose we have this compound AB and AB dissociates as A plus and B minus, then A plus will move towards the cathode because it is positively charged. So it will move towards the negative electrode, and B minus will move towards the anode. Since it is negatively charged, it will move towards the positive electrode. This was the concept of electrolysis. So from electrolysis, there was a conclusion that like charges repel and opposite charges attract. With this concept, we will start about the discovery of electrons. So, discovery of electrons were tried by many scientists. They had tried an experiment which is known as the cathode ray experiment. There they had taken a glass tube, and within the glass tube they had placed two electrodes. It looked something like this. And these two electrodes were connected with a battery. This is the anode and this is the cathode, and there was a gas inside the tube. Let's consider hydrogen, and the pressure was controlled by a vacuum pump. This experiment was carried out in low pressure and high voltage. Now, hydrogen gas is H2, which can dissociate into 2H. When electricity is passed through it, one hydrogen atom gives H plus and one electron. So these electrons were released from the gas, and these electrons moved towards the positively charged electrode, that is the anode. In this experiment, they created a perforated anode, and this wall which was behind the anode, they coated it with a fluorescent or phosphorescent substance. In this case, they used zinc sulfide. So when these electrons entered through the anode and hit the zinc sulfide wall, they created a bright spot. This was the cathode ray experiment. At that time, there was no concept of electrons. They named these negatively charged particles or negatively charged rays as cathode ray. Now we will see the results of cathode ray experiment. First of all, it was concluded that some negatively charged particles are present inside the atom, which was named as cathode ray particle. Later the term electron was coined. So the second conclusion was that these negatively charged particles are themselves invisible, that is, you cannot see them with naked eye. But the presence of these particles were confirmed because they created a bright spot on the zinc sulfide wall. In the absence of electrical or magnetic field, these particles travelled in a straight line. But in the presence of electrical and magnetic field, it was observed that these particles acted in a way in which negatively charged particles should act. Therefore, it was concluded that these electrons are actually negatively charged particles. But at this point, only electrons were confirmed. Any property of electron was not confirmed at this point. The mass and charge of electrons were later found out through two different experiments. One was J.J. Thomson experiment and another one was Millikan oil drop experiment. So, we will discuss about J.J. Thomson experiment and Millikan oil drop experiment. In J.J. Thomson experiment, the charge to mass ratio of the electrons were found out. At that point, they couldn't find out the charge and mass separately, but the value of this ratio was found out. And later on in Millikan oil drop experiment, the charge of electron was found out. So, before going to these two experiments, we need to know certain basic concepts like the electric force, electric field and magnetic force. So, what is electric force? By Coulomb's law, we know that electric force has a formula K Q1 Q2 by R square, where Q1 and Q2 are the charges of two particles and R is the distance between them and K is a constant. Electric field E is written as Q into F, that is the multiplication of charge and electric force gives electric field, and magnetic force Fm was written as BQV, where B is the magnetic field strength, Q is the charge, and V is the velocity of these particles. So, with these three formulas, we will go ahead with the Thomson experiment and Millikan oil drop experiment. Thank you.